Okay, so yesterday we talked about two different types of things in a triangle. We talked about what a perpendicular bisector was, right? What's a perpendicular bisector? Okay, it goes through a segment, creates a 90-degree angle, a right angle, and it makes the two segments congruent. So it goes through the midpoint, right, of a segment, makes the two parts congruent, and it creates four right angles, right? Okay. Now, if you draw all three of them in a triangle, where do they intersect? What? The circumcenter, right? And what special relationship does the circumcenter have in a triangle? It's equidistant to the vertices, okay? Equidistant to the vertices, okay. Then we talked about an angle bisector, right? An angle bisector, that's an angle with two congruent parts, right? What happens when you draw all three of them in a triangle? They intersect in the incenter, right? And what's the incenter's relationship in the triangle? It's equidistant to the side. So they kind of have the opposite relationship, right? The perpendicular bisector bisects the segment, but it's equidistant to the vertices of the angle. And the incenter bisects the angles, right? But it's equidistant to the side. That's kind of how I remember it. They have the opposite, kind of relationship there. Well, today we're going to talk about a median. And a median of a triangle is a segment with its endpoints being a vertex of the triangle and the midpoint of the opposite side. If you're driving down the road, where's the median? The median of the road is in the middle, right? Not on the side of the sidewalk. Okay, the median is in the middle, right? Okay, so when you talk about the median of a triangle, it is a segment that goes from a vertex to the middle or the midpoint of the opposite side. That's called a median. So this CE right here is a median. And your median always has to come from a vertex. Now, your perpendicular bisector went through the midpoint also, but it doesn't necessarily have to come from a vertex. Okay, it's just a segment that is perpendicular and goes to the midpoint. Your median has to come from a vertex to the midpoint of the opposite side. And it's not always going to be perpendicular. It might sometimes be, but it won't always be. Okay? Alright, now, if you draw all three medians of a triangle, they intersect at a point called the centroid. So, let's say this red AD is a median, my CF is a median, and my BE is a median. Going from a vertex to the midpoint of the opposite side. They all intersect at this point right here, and that point is called a centroid. Okay, that point is called a centroid. Now, the centroid of a triangle is the center of gravity of that triangle. It is the balancing point or the center of gravity for a triangular region. It is the balancing, two letters together there. It is the balancing point or center of gravity for a triangular region. So does anybody know what a mobile is? You ever make mobiles in church where things hang off of them? This is kind of a mobile right here. Like, like on a baby's bed, they have little mobiles that they kick in and they make noise to it. Okay. If you had a triangular mobile and you wanted it to lay perfectly flat, you would have to attach the string, from the ceiling or whatever to the mobile. You would have to attach it at the center. If you had a triangular table and you wanted it to lay flat and not break off or tip, you would have to put the pole that holds it up, you would have to put it in its centroid. And if you did, it would make it lay flat because it's the balancing point, the center of gravity for that region. Okay? So that's what this little thing is right here. Now, the centroid has kind of a weird relationship. Not like what we talked about yesterday, which was still kind of weird, but this is even stranger. Let's look at this red segment, okay? When you're talking about the centroid, you've got a shorter part, a longer part, and you've got the entire median, okay? And the centroid breaks it up into 1/3 and 2/3 parts. The shorter part, which is from the centroid to the midpoint, is 1/3 of the entire median. The longer part from the vertex to the centroid is 2/3 of the entire median. And then this shorter part here is half the longer part, because 1/3 is half of 2/3, right? So this shorter part is half the entire median. The longer part is 2/3 of the entire median, and then the short part is half the long part. Okay? So let's do an example. Okay, it says in triangle ABC, Q is the centroid. Now we're going to look at this little segment right here. Okay? Q is my centroid. It says if BE is 9, we want to find BQ and QE. So we want to find this part and we want to find that part. Okay? BQ and QE. What would be the easiest thing to find first if the whole thing is 9? What? QE? Okay. QE is 1/3 of that, right? What's 1/3 of 9? 3. Okay? This is 2/3 of that, or this is half of that, or BQ is 2 times QE. So what would BQ be? 6. And then the whole thing is 9. Okay. Let's do another one. Let's say QD is 2. And I want to find AQ and AD. So we're going to do this thing here. So, if QD is 2, what can we find? AQ, which means it's going to be 4, and then the whole thing's going to be 6. Okay? Let's do one more. This time, let's do this one. And I'm going to tell you, say this right here is 10. So if QC is 10, what could I find? FQ, which is going to be half that, which is 5. So then the whole thing is going to be good. Alright, so that's the relationship within the centroid. It's the center of gravity, and it's got the 2/3, 1/3 relationship. Okay? We'll come back to that in just a second. Now, the next thing we want to talk about is the altitude. Okay? And the altitude is of a triangle is the segment from a vertex perpendicular to the opposite side. Okay, so it goes from a vertex perpendicular to the opposite side. It is the height of the triangle. So it goes from the vertex and it goes perpendicular to the opposite side. Sometimes that altitude is inside of a triangle, like in an acute triangle, it's going to be inside. But in an obtuse, sometimes it comes outside and you have to extend the base. So if I wanted to go from B to AC, I'm going to have to extend AC and then drop my altitude or my height. In a right triangle, sometimes the altitude is actually the side of the triangle. Okay? So this is A, B, C. Okay? In this case, BC is an altitude, which is also a side of the triangle. Now, if I drop all 3 altitudes in a triangle, okay, here's one, goes from the vertex, perpendicular to the opposite side, from the vertex, perpendicular to the opposite side, and from the vertex, perpendicular to the opposite side. I've drawn all 3 of them. They intersect at a point called the orthocenter. They intersect at a point called the orthocenter. It doesn't really have a special relationship that I know of, so I just want you to know that the altitudes of a triangle intersect at the orthocenter. Okay? So that's the main thing that you got to know about that. Alright, so let's put all 4 of these together. Okay, so the first one we talked about was a perpendicular bisector. Okay, just a few minutes ago we said that a perpendicular bisector does what to a segment? It divides into 2 parts, so it goes through the midpoint, and what? When it goes through, what does it do? It makes 90-degree angles, right? It makes 4 right angles. Okay. So that's a perpendicular bisector. If I drew all 3 of them, like I did over here, these three black lines here, FP, DP, and EP, what's their point of concurrency? Circumcenter. Okay, and what special property does that circumcenter have with the triangle? It's equidistant to the vertices. Good. Equidistant to the vertices of the triangle. Okay, so an angle bisector, what does an angle bisector do? Bisects the angle, which means what? Okay, it breaks it into angle into two congruent parts, right? Okay, and if you drew all three of them in a triangle, what's their point of concurrency? In center. Okay, so the in center over here is Q, and that's created by AQ, CQ, and BQ, right? And then what's that point special relationship to the triangle? It's equidistant to the sides. Alright? What does a median do? Okay, what? Okay, it has to come from a vertex and it divides the opposite side in half, right? It goes to the midpoint, correct? Okay, from the vertex to the midpoint of the opposite side, okay? And if I were to draw all three of those, they intersect at the centroid. This is the one that's kind of got the weird relationship. Let's use segment AD, okay? B is the centroid, right? And so PD is what? It's 1/3 of AD. It's 1/3 of the whole thing, which is AD, okay? AP is what? Is 2/3 of the whole thing. And then what's the, what other relationship does PD have? It's half of AP, or you could say AP is 2 times PD, right? Okay. Alright, good. And then, the last one we talked about was the what? Altitude. And an altitude does what? It's the height, so it goes from the vertex perpendicular to the opposite side, right? Makes a right angle. It's the height of the triangle. Okay? And what is its point of concurrency? Orthocenter. Now, I would venture to say that most of the time, each one of these pieces of the triangle were different segments most of the time, right? But do you think that they're ever all one and the same? You think in any kind of triangle that your perpendicular bisector, your angle bisector, your median, and your altitude are all the same segment? You think that would ever happen? Huh? In an equilateral triangle, very good. Okay? If you have an equilateral triangle, remember I told you that when you drop your height, we talked about this last week or week before, we dropped your height, it also went to the midpoint of the opposite side, right? So this is an altitude, it's a midpoint, and since it goes to the midpoint and it's perpendicular, it's also a perpendicular bisector, right? Okay? And remember I told you that when that happens, it creates two congruent triangles, so it's an angle bisector too. And that would happen from every vertex in an equilateral triangle. So in that situation, all four of those are the same segment, but they're not always the same. Your perpendicular bisector normally doesn't even have to come from a vertex. In this case, it did, okay, but it doesn't always have to, okay? It just has to be perpendicular and go to the midpoint. All right, are there any questions? Okay, your assignment is on the board. I omitted a couple of them. That we'll maybe talk about one of those tomorrow in class. But we omitted 4, 12, and 14. Now that last part, the work page, for whatever reason, because of the Veterans Day, something or other, I don't know. I think most of you guys will be here. I won't see my 5th hour, so that's their assignment. Okay, for tomorrow. That's the work to do tomorrow, so don't worry about that tomorrow.